In this example, we're going to work through and solve this equation. We're going to solve it for m, it looks like, is our variable. And we're going to do so and include here a two-column algebraic proof. So not only are we going to solve the equation, over here on the right, we're going to give justification for every single step that we take along the way. Now, these two-column algebraic proofs are a great way to get you prepared for the more rigorous proofs that you'll see in geometry. So let's go ahead and get started. So the first reason that we always give is just, well, given. Because this equation was given to us. So that's what we're going to do. We're going to solve it. Okay, so looking specifically at this equation, we've got some parentheses here. Let's go ahead and get rid of these parentheses, and we can do so by going ahead and distributing this 2 across this binomial 4m minus 5. Okay, so what will that look like? Well, 3m minus 10 will equal, the distribution will be 8m minus 10, and then of course that plus 10. So what's the justification? What's the reasoning behind what we just did that allowed us to go from this step to this step? Well, it was just the distributive property. So we can just write that down. Distributive property. Okay. Well, how about now? What do we have? Well, we have 3m minus 10 equals, and we have this 8m minus 10 plus 10. So on this right side, I have these two numbers that I can go ahead and put together. And in our case, negative 10 and positive 10 actually cancel each other out and will give us a 0. So 3m minus 10 will just equal this 8m. So what justification can we give from going from this step to this step? Well, we just combined like terms. So we'll say combine like terms. Okay. Well, let's see where we are now. We have a variable on the left side and the right side, but we have a number just on the left side. So let's go ahead and collect our variable terms on the right and leave this negative 10 on the left right where it is, because he's just fine where he is. So this 3m right here is a positive 3m. So to do the opposite here, we need a negative 3m. So what it looks like we're going to do is subtract 3m from both sides of this equation. So this is going to be called the subtraction property of equality. And this property just states that if I'm going to subtract something from one side of the equation, I need to do it to the other side as well, just to keep everything nice and equal. Okay, well, what happens in doing so? Well, I see this 3m and this negative 3m will cancel each other out. And so we have just the negative 10 over here on the left. How about the right side? Well, 8m minus 3m, it will be 5m. And that's going ahead and actually doing that subtraction. So the justification that we say here will be simplify. So the subtraction property of equality told us we wanted to subtract 3m from both sides. And actually going ahead and doing that subtraction and seeing what we have for the next step, that'll be simplify. Okay, so I'll move up a little bit. So it looks like we have negative 10 equals 5m. So this 5 is being multiplied by the m. But remember, we're trying to get this m all by itself, so we can isolate it on one side so we can say m equals. Okay, so if the 5 is being multiplied, the opposite of multiplication will be division. So let's go ahead and divide both sides of this equation by 5. And the justification that we can give for doing such a step will be the division property of equality. All right, so now let's actually go ahead and do this division. So negative 10 divided by 5 will be negative 2. And over here on the right, the 5s will cancel. So I have negative 2 equals m. And once again, that's just simplify. So after you get going doing some of these, you'll notice that after you do a property of equality, you're typically going to do a simplify afterwards to go ahead and kind of clean things up a little. So one final thing you could consider doing, a lot of students like to see this variable on the left side of the equation instead of the right side. So we could switch those two and just say, instead of negative 2 equals m, we could say m equals negative 2. And the justification, or the property that allows us to do this, is called the symmetric property of equality. And this just states, if we have an equation and we're saying that both sides are equivalent to one another, then I can just go ahead and exchange the two sides, the left side for the right and the right side for the left. So we see that m equals negative 2. So let's go back up to the top. We started with our equation here, and the reason here was given, of course. And then we walked through on the left side and we solved our equation. And on the right side we gave justification for every step that we took along the way until here we were at the bottom and we saw that m equaled negative 2.